Shenzhou. Shenzhou, simplified Chinese,
Shenzhou,
pinyin Shenzhou, is a Chinese spacecraft developed for the nation's crewed space program, China Manned Space Program, CMS, also known as Project 921. Its design was based on Russia's Soyuz spacecraft, but larger and modernized. Like Soyuz, Shenzhou is a single-use vehicle composed of 3 modules. A descent module which houses the crew during launch and re-entry, an orbital module which provides additional living space and storage during orbit, but is jettisoned before re-entry, and a service module responsible for propulsion and power, also discarded before re-entry. For added safety and aerodynamics, the spacecraft is encased within a payload fairing and fitted with a launch escape system, LES, during liftoff. Its maiden uncrewed flight, Shenzhou 1, was on November 19, 1999, with the first crewed mission, Shenzhou 5, taking flight on October 15, 2003. It is slated for replacement by the next-generation Mengzhou, currently in development, with a 2-module configuration. The literal meaning of the native name,
Shenzhou,
pinyin Shenzhou, is, the divine vessel on the heavenly river, to which heavenly river,
天河,
means the Milky Way in classical Chinese.
Shenzhou,
is a pun and neologism that plays on the poetic word referring to China,
神州,
meaning divine realm, which bears the same pronunciation. For further information, refer to Chinese theology, Chinese astronomy, and names of China. China's first efforts at human spaceflight started in 1968 with a projected launch date of 1973. Although China successfully launched an uncrewed satellite in 1970, its crewed spacecraft program was cancelled in 1980 due to a lack of funds. The Chinese crewed spacecraft program was relaunched in 1992 with Project 921. The Phase 1 spacecraft followed the general layout of the Russian Soyuz spacecraft, with 3 modules that could separate for re-entry. China signed a deal with Russia in 1995 for the transfer of Soyuz technology, including life support and docking systems. The Phase 1 spacecraft was then modified with the new Russian technology. The general designer of Shenzhou 1 through Shenzhou 5 was Qi Faran, simplified Chinese,
齐发任,
and from Shenzhou 6 on, the general design was turned over to Zhang Bainan, simplified Chinese,
张伯南.
The first uncrewed flight of the spacecraft was launched on November 19, 1999, after which Project 921-1 was renamed Shenzhou, a name chosen by then Chinese President Jiang Zemin. A series of 3 additional uncrewed flights were carried out. The first crewed launch took place on October 15, 2003 with the Shenzhou 5 mission. The spacecraft has since become the mainstay of the Chinese crewed space program, being used for both crewed and uncrewed missions. Shenzhou consists of 3 modules, a forward orbital module, simplified Chinese,
轨道舱,
pinyin, guidaocang, a re-entry module, simplified Chinese,
返回舱,
pinyin, fanhuicang, in the middle, and an aft service module, simplified Chinese,
推进舱,
pinyin, tujinsang. This division is based on the principle of minimizing the amount of material to be returned to Earth. Anything placed in the orbital or service modules does not require heat shielding, increasing the space available in the spacecraft without increasing weight as much as it would if those modules were also able to withstand re-entry. The orbital module, simplified Chinese,
轨道舱,
pinyin, guidaocang, contains space for experiments, crew-serviced or crew-operated equipment, and in-orbit habitation. Without docking systems, Shenzhou 1 to 6 carried different kinds of payload on the top of their orbital modules for scientific experiments. The Chinese spacecraft docking mechanism, beginning with Shenzhou 8, is based on the Androgynous Peripheral Attach System, APAS. Up until Shenzhou 8, the orbital module of the Shenzhou was equipped with its own propulsion, solar power, and control systems, allowing autonomous flight. It is possible for Shenzhou to leave an orbital module in orbit for redocking with a later spacecraft, a capability which Soyuz does not possess, since the only hatch between the orbital and re-entry modules is a part of the re-entry module, an orbital module is depressurized after separation. For future missions, the orbital modules could also be left behind on the planned Chinese Project 921-2 space station as additional station modules. In the uncrewed test flights launched, the orbital module of each Shenzhou was left functioning on orbit for several days after the reentry module's return, and the Shenzhou 5 orbital module continued to operate for 6 months after launch. The reentry module, simplified Chinese,
返回舱
pinyin, Fanhuizang, is located in the middle section of the spacecraft and contains seating for the crew. It is the only portion of Shenzhou which returns to Earth's surface. Its shape is a compromise between maximizing living space and allowing for some aerodynamic control upon re-entry. The aft service module, simplified Chinese,
推进舱
pinyin, Tujinsang, contains life support and other equipment required for the functioning of Shenzhou. 2 pairs of solar panels, 1 pair on the service module and the other pair on the orbital module, have a total area of over 40 square meters, 430 square feet, indicating average electrical power over 1.5 kilowatts. Soyuz have 1.0 kilowatts. Although the Shenzhou spacecraft follows the same layout as the Russian Soyuz spacecraft, it is approximately 10% larger and heavier than Soyuz. It also has a bigger cylindrical orbital module and 4 propulsion engines. There is enough room to carry an inflatable raft in case of a splashdown, whereas Soyuz cosmonauts must jump into the water and swim. The commander sits in the center seat on both spacecraft. However, the pilot sits in the left seat on Shenzhou and the right seat on Soyuz. The Shenzhou was prominently featured in the film Gravity and was used by the main character, STS-157 mission specialist Dr. Ryan Stone, to safely return home after the destruction of her spacecraft. In Star Trek, Discovery, the Walker-class starship USS Shenzhou is named after this spacecraft.